This is Saxon 4, Lesson 27, Multiplication as Repeated Addition and Elapsed Time Problems. Now, the reason I'm not separating elapsed time problems into a second part is because we've already done them. This should just be a little bit of a review and an extra practice, so I'm keeping them in the same lesson today. So, multiplication as repeated addition. So, when you're looking at multiplication, you normally look at something like this. Two groups of 4. Because remember, this actually says groups of. Okay, so 2 groups of 4. So that actually translates really nicely into we're doing it as repeated addition because you have 2 groups of 4. This and this are equivalent. They are the same. Okay, this is 2 groups of 4. This is 2 groups of 4. Both of them make the same number. So when you're turning multiplication into repeated addition problems, all you're doing is taking whatever number you're timesing and doing how many groups of it there is. Example, if I had 10 groups of 7, I would turn this into a repeated addition problem by doing 10 sevens, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's my repeated addition for 10 times 7. Because remember, 10 times 7 is just 10 groups of 7. This is 10 groups of 7. Okay, they're the same thing. So when you're doing repeated addition and multiplication, you're just looking at this is kind of the shorter version of this. Okay, let's do one more. We'll do it the opposite way, where we'll have 6 plus 6 plus 6 plus 6. If you're given this and you're asked to turn this repeated addition problem into a multiplication problem, you start off with, well, I know we are doing groups of 6s, and I have 1, 2, 3, 4, 4 groups of 6. Okay, that is repeated addition and multiplication and their connection to each other. When you're looking at elapsed time problems, there's really 2 ways to do it. I like doing it with clocks, but there's other ways you can do it as well. If you're really good at working with different bases, you could do a base 60, but we're not going to go into that too much. I can show you, but we're going to do it a couple other ways. So we have a clock, and our clock says it is 1:45. Okay, make that a little bit shorter so you get the idea. Okay, it is 1:45. All right, or 1:45. And we need to look at 1 hour and 50 minutes in the future. Okay, so what is 1 hour and 50 minutes in the future? So how I can do that is 2 ways. The way I like to do it is just do 1 hour to start with. So 1 hour equals 60 minutes. Okay, so 1 hour is 60 minutes. So that means that normally what that would mean is that going from 12 all the way around back to the 12. But you can do that from any number. So if I take my big hand from the 9 and go all the way around back to the 9, that's an hour. Okay, so I've done that. And while I've been doing that, this hand has moved down to there. Okay, so we now have 2:45. Okay, 2:45 is 1 hour's difference. Okay, because if you notice, I added the 1 hour, 1 and 1 is 2, 2 is there. I haven't changed the minutes yet, so the minutes have stayed the same. Okay, now a lot of you are going to say, well, why don't you just add 50 minutes? Because 1 hour is 60. So this is a base 60. So we can't go up to 100 like we normally would. So if you can do it thinking of 60 as 100, you can do that. But we're going to do it counting. So we're now going to take this and we are going to count. Okay. Now remember, this is the minute hand. This is the hour hand. Okay. So I'm going to take my minute hand. I've used my hours. I'm now going to do 50 minutes. So each of these is 5 because for each hour, so for each 1 hour, you were looking at timesing it by 5, whatever the hour is. So whatever hour, you times it by 5 to get the minutes. So for example, 3 times 5 equals 15 minutes. That means the 3 on my clock is 15 minutes. Okay, so I'm going to count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So that means this hand has come all the way around to here. Okay, big hand is now pointing there. My little hand has gone to the 3. I'll erase these. We now have 3, because I passed that 60 mark, 3:35. Okay, and 3:35 is your time. Okay, so that's the way I like to do it. I like to look at the hours, do the hour first, and then do the minutes. Okay, because if you try and count it all out on the clock, it sometimes gets a little bit frustrating if you're doing it by a drawing. I will show you the base 60 way so you can see it, but I don't expect you to solve it this way. So base 60 is you have an hour and 45 minutes and you're adding an hour and 50 minutes to it. Okay, now because it is base 60, this number can't go past 6. Okay, so this tens column can't go past 6 if it's a base 60. So we're doing 4 add 0, okay, or sorry, 5, not 4. 5 add 0 is 5, and then 4 add 5 is 9. Now I can't do that. I have, let's put 9 over here. Okay, 9 is how many more than 6? Okay, if I wanted to figure that out, I could do 9 take away 6 would be 3. So that means 3 stays here, and my whole 60 comes over here. Okay, this is why I said we probably won't solve them this way, but I'll show you it so that you can see. Okay, so the 60 is 1 hour. Then we add up our hours, 3 hours, and we have 3:35. So you can add them, it does work. You just need to remember that because it's a base 60, you're only in your tens column going up to 6 and then having to round and regroup. I would do it this way. It's a little bit simpler, where you just move the hands around as you go, counting by 5s. Okay, that was lesson 27, multiplication as repeated addition and elapsed time problems. Remember, elapsed time problems should have been a review, so if you need to go back over it, go back to that original lesson.